Okay, so uh, we're diving into this Strömlingo DIY AFM thing.
Right.
And honestly, even just saying the name is kind of cool.
It's catchy.
DIY atomic force microscopy.
Yeah, you don't see those words together every day.
Not every day. So
Uh-huh.
we've got these 3 videos, and they make some pretty big claims, right? Like, this could be huge EE for research.
Definitely. The potential is there, for sure.
Affordable, customizable, powerful enough for serious research.
Yeah.
But is it really all that?
Well, that's what we're here to figure out.
Right. So first things first, what is atomic force microscopy? I mean, I get the microscopy part, but...
It's like being able to see individual atoms on a surface.
Get out! No way!
Yes. Well, not with your eyes, obviously.
Right.
It uses this tiny probe, like a microscopic finger, to trace the surface of materials.
So, like, feels the atom.
In a way, yes. And those tiny interactions help us create images of the surface at the nanoscale.
Wow. Okay, so we're talking, like, incredibly small details here.
Exactly. Details you wouldn't be able to see with even the most powerful optical microscopes.
So it's not just about seeing things really, really small, but understanding what's going on at that level.
Exactly. It's about analyzing the structure, the properties, the behavior of materials at the atomic level.
That's insane. Okay, so this Strömlingo thing is supposed to make that kind of tech more accessible.
That's the claim, and that's what has everyone so excited.
One video even said it's less expensive than a Mac Pro, which just sounds crazy to me.
It is disruptive, price-wise, for sure. Now, keep in mind, it's like any starter kit. The base price gets you going, but upgrades and modules will add to the cost.
Right. But still, even that starting point being that accessible is a big deal.
Huge. Especially for smaller labs, independent researchers, universities. It could be a game changer.
Okay, so let's say I'm sold on the idea. How does this DIY thing actually work? Do I need to be, like, a tech genius to put it together?
Well, they're really pushing the user-friendly angle. One video even mentioned assembling it in an hour.
An hour. Seriously.
That's what they said. It's like high-tech Legos, apparently.
Okay, but even if I manage to build the thing, actually using it for research is a whole other story, right?
Yeah.
I mean, you can give me the fanciest oven in the world, but that doesn't mean I can bake a souffle.
Exactly. There's more to it than just putting the pieces together. You need to know how to calibrate it, prepare your samples, interpret the data.
Right, of course. So this is where having some background knowledge of AFM comes in.
Exactly. You need to understand the underlying principles to really make the most of the technology.
So it's not exactly a toy, even if the assembly is simple.
Definitely not. But it does open up possibilities for people who might not have had access to this kind of tech before.
That's amazing. But what about people like me? I'm interested in this stuff, but I'm not a scientist. Can you break down what kind of research you can actually do with this Strömlingo DIY AFM?
Sure. With atomic force microscopy, you can do things like analyze the surface of new materials.
Oh, interesting. Like what kind of materials?
Anything, really. From semiconductors to biomaterials, you name it. You can study biological samples like DNA or proteins, even manipulate individual molecules.
Wow. That's incredible. So it's used in all sorts of fields then?
Absolutely. Materials science, nanotechnology, biotechnology.
Yeah.
The applications are vast.
Wow. Okay, so this DIY kit has the potential to open up all of those fields to more people.
That's the hope, anyway.
I'm intrigued. One thing that caught my eye in the videos was the mention of open source software.
Yes.
And Arduino compatibility. Now, I know a little bit about Arduino from some DIY electronics projects, but how does that tie into this high-level research equipment?
That's one of the coolest parts, honestly, that Arduino compatibility means researchers can tinker with the AFM's control systems, customize them for unique experiments.
Like actually change how the device works?
To an extent, yes. And you can even integrate it with other lab equipment.
So it's not just a standalone microscope. It can be part of a bigger setup.
Exactly. The possibilities are pretty amazing.
So this isn't just about making AFM more affordable. It's about making it more open and flexible.
Exactly. They're giving researchers the tools to really push the boundaries of what's possible with AFM.
That's incredible. But wouldn't that require some serious coding skills? I mean, I dabble in Arduino, but this seems next level.
And that's where the open source community comes in. They showed in one video that there's already a vibrant community online sharing code, modifications, troubleshooting tips.
So even if you're not a coding whiz, you can benefit from the collective knowledge of the community.
Exactly. It's like having a global team of collaborators helping you unlock the full potential of this DIY AFM. It's pretty cool, right? They're really fostering this whole ecosystem around this technology.
It's pretty impressive, actually. And speaking of ecosystems, didn't it mention something about this DIY AFM being modular?
Yeah. You can start with a basic setup and then add on components as your needs evolve.
Oh, right. So it's like a nanoscale research starter kit that you can upgrade over time.
Exactly. Need a specialized probe for a particular measurement. You got it.
Oh, wow.
Want to control the environmental conditions of your sample more precisely? There's a module for that.
Really?
Even high-speed imaging to capture dynamic processes. It's all possible with this system.
That's incredible. So you really can build a pretty sophisticated setup with this thing.
Absolutely. It's like having a nanoscale laboratory at your fingertips. And the best part is you only pay for what you need when you need it.
Okay, that's actually pretty smart. But with all this talk about research and stuff, what about the educational side of things? The video's touched upon that, but I'm curious to hear your take. What kind of impact could this DIY AFM have in classrooms?
Oh man, the educational potential is huge. Imagine, instead of just reading about nanoscale phenomena in a textbook, students can actually build and use the tools to explore them firsthand.
Right. It's one thing to memorize facts, but actually experiencing the science is a whole different level.
It's like, remember those old build-your-own-volcano kits? This is like that, but for the nanoscale.
Yeah. Except instead of vinegar and baking soda, we're talking about like manipulating individual molecules.
Exactly. It's hands-on learning at its finest. And it's not just about building the AFM either. It's about understanding how it works, troubleshooting problems, analyzing data.
Right. It encourages critical thinking and problem-solving skills.
Absolutely. Skills that are essential in any STEM field.
And who knows, maybe even inspire some future scientists and engineers along the way.
I'd say that's a pretty safe bet. There's something so powerful about giving students the tools to explore the world at such a fundamental level. It sparks curiosity, it ignites passion, and who knows what amazing discoveries they might make.
I love that. Okay, so we've covered a lot of potential benefits here, but are there any downsides to this DIY approach? It seems almost too good to be true, you know?
You're right to be cautious. It's not all sunshine and roses. There are some potential drawbacks to consider.
Oh, okay. Like what should we be watching out for?
Well, for starters, the DIY aspect, while empowering, could also be a challenge for some. Not everyone is comfortable tinkering with electronics or delving into lines of code, even with a supportive online community.
That's a good point. It's not for everyone, that's for sure. I mean, I consider myself pretty tech savvy, but even I get intimidated sometimes.
Yeah. And then there's the issue of quality control with open source software. While the collaborative aspect is fantastic, it also introduces the possibility of variations in code or modifications that could affect the accuracy and reliability of measurements.
Oh, I see. So it's like a double-edged sword. You're gaining flexibility and affordability, but potentially sacrificing some reliability and consistency.
To some extent, yes. It highlights the need for robust documentation, standardized testing protocols, and a rigorous peer review process within the DIY AFM community.
So how do we address those challenges? I mean, how do we make sure this technology is used responsibly and that the data being collected is reliable?
That's the million-dollar question, right? And I don't think there's a simple answer, but I do think open communication and collaboration are key.
Can you elaborate on that?
Sure. If researchers are transparent about their modifications, the challenges they face, the results they're getting, it can help create a more robust and reliable ecosystem for everyone.
So it's about building trust within the community.
Exactly. And that's something the scientific community has a lot of experience with. Think about peer review, for example. It's a process designed to ensure the quality and validity of scientific research. The same principles need to be applied in this new landscape of DIY scientific instruments.
So it's like a peer review system, but for the hardware and software.
In a way, yes. It's about creating a culture of transparency and accountability within this DIY AFM community.
That makes sense.
Huh?
Because at the end of the day, researchers need to be confident in the data they're collecting.
Absolutely. Especially if they're going to share it with the world.
Exactly. So, okay, big picture time. We've talked about the potential benefits, the challenges, the need for collaboration. Where do you see this technology going in the future?
It's tough to say for sure, but I think we're just scratching the surface of what's possible.
You really think so?
I do. Imagine a world where advanced research tools like AFMs are no longer confined to expensive labs.
Right, where anyone with an internet connection and a little bit of know-how can explore the nanoscale.
Exactly. And imagine the kind of innovation that could unlock. Students, citizen scientists, researchers in developing countries, all with access to these incredible tools.
It's like the democratization of nanoscience research.
Exactly. And Who knows what kind of amazing discoveries are out there waiting to be made once we break down those barriers to entry.
It's pretty exciting to think about.
It really is. This Strømlingo DIY AFM is just one example of a much larger trend.
Oh, amazing.
We're seeing this kind of open source DIY approach popping up in all sorts of scientific fields.
Really?
Yeah. From telescopes to DNA sequencers, people are finding ways to make these powerful tools more accessible and affordable.
So it's not just about the tools themselves, it's about changing the culture of science itself.
I think so. It's about breaking down barriers, fostering collaboration, and empowering a new generation of explorers and innovators.
I like the sound of that.
Yeah.
But like we've been discussing, it's not without its challenges, right? This new frontier of DIY science comes with its own set of risks and responsibilities.
For sure. And it'll be interesting to see how those play out in the years to come.
Definitely food for thought. Well, this has been a fascinating deep dive.
It has.
We've covered so much ground, from the nitty-gritty of atomic force microscopy to the potential impact of this DIY revolution in science.
And we've only just scratched the surface.
Right. So much more to explore, so many questions still unanswered. But that's the beauty of science, isn't it? It's all about asking questions, pushing boundaries, and never being afraid to dive into the unknown.
Well said.
So, to our listeners, we want to hear from you. What are your thoughts on this whole DIY AFM thing? Is it a game changer? A passing fad? Something in between? Head over to our website, leave a comment, send us an email, whatever you like.
We love to hear what you think.
Because this is a conversation that's just beginning, and we all have a part to play in shaping the future of science. Until next time, keep exploring.